Okay, so today's question is minimum cost to cost part with edge reversal. This is the question from Biweekly contest 163 of the Leetcode. Okay, so you are given a directed graph with the weight. Okay, so the graph was given the kind of like 0 to 1. This is the edge from 0 to 1 and with the weight of 3. This is kind of graph that we are given. Okay, and this is the main statement. This is the main problem statement. You can read it. I am going to explain it on the tab, and we have to find like minimum distance from 0 to n minus 1 node. Like in this case we have 4 nodes. That means we have to find the minimum distance from node 0 to node 3. Okay, so let me explain you the problem. Okay, so this is the graph that we are given, and we have to find the minimum distance from node 0 to 3. Okay, so if you carefully observe, like in the problem statement, this says like this is the statement: each node u has a switch that be used at most once. When you arrive at u, you have not yet used its switch, you activate one reversal. Okay, so and if you wanted to reverse it, you have to pay double the cost. This is the edge cost, 2 into weight of I. So let me explain you what they are saying. So from 3 to 1 there is a edge with the cost of 1, but from 1 to 3 there is no direct edge. Okay, so if you wanted to put that edge, you have to double the cost. You have to double the cost. This is the cost, that is 1, and if you double it, you can now grow from 1 to 3. Okay, if you just apply, like this is the shortest path from source to destination. Which algorithm comes to your mind is Dijkstra's algorithm. Okay, the Dijkstra's algorithm, this is used for undirected graph with like no negative cycles. Okay, so just apply this algorithm on this graph, then I am going to add these edges. Okay, so let me first show you without doing anything. Just apply Dijkstra's algorithm. Okay, so if you apply Dijkstra's algorithm, we can go from 0 to 2 and then 2 to 3. The cost of 0 to 2 is 2 and the cost of 2 to 3 is 4. Okay, so 2 plus 4, the cost will be 6. But if we add this edge, okay, from 1 to 3, and the cost become double, so 2. And now the optimal path is 0 to 1 and 1 to 3, right? So the cost from node 0 to 1 is 3 and 1 to 3 is 2. Okay, the total cost become 5. Why? We just have to add, and we don't know which reversal technique helps us or not. Like we can add this edge with the distance 6. For that we are just simply adding the we are just simply doing the Dijkstra's algorithm. Okay, and the simple trick is we just have to apply Dijkstra's algorithm on the given graph, but with the nodes, like with the reversal node. Like we can reach 0 to 1 with a distance of 3, but we just need to add this node like 1 to 0 with the distance of 6, 0 2 to 0 with the distance of 4, because the distance is 2. That is the main idea. Okay, so let's try run on this question. I have a like full setup. Okay, so this is the question. In Dijkstra's algorithm, we have a like distance array, and this is the distance array. Initially we are at the 0 node, so for reaching the 0 node we don't need to traverse any distance. Okay, and this is 4, this is 8. Okay, so now let's do our dry run. Okay, for first element we have like 0 for to 0. Okay, just add a 0 and comma 0. Okay, this is the priority queue. That means that it means that we are reaching with the distance of 0 on the node 0. Okay, so the the neighbors of 0 is you can say the neighbors of 0 is 2 and 1. Okay, let's traverse it one by one. So 0's neighbor is 1. Okay, and to reach the node 1 we have a distance of 3 plus the reach the node 0, that is 0. Okay, initially it was 0, and if you see on the distance array, this is like distance array. On first node the distance was infinity, and which is greater than our current distance. Okay, so we simply going to update it, and this is like 3, and now we are putting it in our priority queue. The distance was 3, and we are going to reach our first node. Okay, now the second neighbor. Okay, second neighbor was 2, so for reaching the 2 is like 0 plus 2, right? So you can see this is the edge. From 0 to 2 we need 2 distance. Okay, and this is less than this value, infinity value, so we are going to update our 2 distance to 2. Okay, and we are going to put 2 and with 2. So this statement means we can reach node 2 with the distance of 2. Okay, so now uh, take our next element. So from our priority queue we can remove our first element, this we traverse it completely. Now the second element with has like minimum weight, minimum cost, and that was 2 comma 2. Okay, so let pop this element like 2 comma 2. This means that we need distance of 2 to reach node 2. Okay, let's see, this is the node 2. The neighbors are like 3 and 0. Okay, to reach 0 we need 4 distance, and we are already coming from 0. Like 0 to 2 is 2 distance, and 2 to 0 is 4 distance. That doesn't make any sense. Okay, so we are simply going to not traverse on that. Okay, the second neighbor is 3. Okay, so to reach the 3 we need how many distance? This is 4. Okay, to reach the third node we need distance 4. So to reach the node 2 we have 2 distance, and to reach the 3 node we have the 4 distance. Okay, this is kind of this, and this edge it cost 2 and it will cost 4. In total this will cost us 6. And in our distance array you can see we have infinity distance, we can't reach. This is like greater than our current, so we are going to update it. Okay, so this is 6. Okay, so now just put it into our priority queue. We reached our destination, but we are not going to return our answer because we can reach with some smaller distance. So we can, the distance is 6 and the node is 3. Okay, now our priority queue, the smallest weight is 3. Okay, so pop 3 comma 1. So 3 with the 1, that means that we can reach node 1 with the distance 3. That you can see, this is the node with the 3 distance. Okay, so now see the neighbors. One neighbor is like 0 and 3, so we are already coming from 0. That doesn't make any sense, so we are not taking the 0. The second neighbor is 3. Okay, so to reach the 3 we have a distance of 2. Okay, this is the node. So the total distance is 3 plus 2, that is equal to 5. And we already have, to reach the third node we have 6 distance, and that is greater than our current distance. So we are going to update it. Okay, so you can see that by reversing this edge, like we don't have this edge. Okay, by reversing this edge and the weight will be double. By doing that we are able to achieve less distance. Okay, now put it into our priority queue with the distance of 5 and comma 3. Okay, now pop our second, now pop our smallest element into the priority queue, like smallest element node with the least weight. And that was this 5 comma like 5 distance we can reach third node. Okay, and whenever we are reaching our destination, and 3 was our destination, so we can simply return our weight, and that was 5. Okay, like we are calculating our like priority queue, we are popping out elements, the nodes which has already the smallest weight. So whenever we are reaching our node destination, we can simply return our answer, that was 5 distance. So I hope you understand it. Let me code the solution. Okay, so that is coding part. Okay, so we have to make the graph first. List of integer. Okay, this is the adjacency list. Okay, so we have to put this like basic steps. So adjacency list dot add new array list. Okay, so how many, like there are 4 nodes, so we have to put 4 array list in that, in this. Okay, so now we are going to make our graph, and this is the important part. Okay, don't skip it. Okay, so we are going to traverse on edges, edges, and we just have to add our edges dot get our 0. This is u. Okay, this is I think I can do that. U is edge of 0. This is v, edge of this is v, and weight is 2. Okay, so we can get our 0th array list, and we can add our destination, that is v comma our weight. Okay, so that it states mean that we have h from u to v with the with the weight of wt. Okay, okay, and this statement, okay, if you wanted to reverse it, the weight becomes double. That means we can have a edge with v to u, right, with the double the weight. Okay, now we are going to simply do the Dijkstra's algorithm. So we are going to first create our distance array, and initialize everyone's with integer integer max value, right? And since we are at our 0th node, so we don't need any distance to traverse on the 0. We are already on the 0th node. Okay, so now add our 0th node, because we already reached there. Int of 0 comma 0, and we have to create priority queue as well. Oh, this is very lengthy, and we have to define our priority queue like heap on our weight. So I am going to put our weight on our first element. Okay, so we have to sort according to weight, and this function will sort. Okay, this custom comparator, I can write custom comparator, but this is equivalent to it. Okay, so unless, so whenever, like until our priority queue become empty, we have to traverse it. Okay, so pair is like qq dot poll, we get the pair, and the weight was pair of 0. This is the weight, and the node is pair of 1. Okay, and now we have to just simply traverse on its edges. Okay, so for h neighbors, like we have to traverse it on the its neighbor, right? So adjacency list dot get node, right? So these are the neighbors, and the neighbor is the neighbor. So the neighbor is this, and to reach that neighbor, the distance is our second element. Okay, and now we just have to check if the weight to reach the node plus the distance. Okay, distance, if it is less than our distance of neighbor, if it is less than, so we just need to update it. Distance of neighbor was weight plus distance. This is like simple Dijkstra algorithm, and when we update it, we just have to insert it into the our window. We just need to update our the distance is distance of neighbor comma the neighbor. Okay, so this is the distance, this is the distance to reach the neighbor. Okay, and if we don't able to reach our destination, okay, okay, so okay, when we reach our destination, when we reach our destination, like final destination 3 in this our example. Okay, so the node is equal to n minus 1, we just need to return our weight. Okay, so let's see if it is work or not. It has to work, but let's see. Oh, it is running without giving any error. Let's see. Yeah, it is getting accepted. I wrote the entire code without any mistake. If you like, then subscribe and do the comment. I understood. Thank you so much for watching. Bye bye.